Hi students, today we are going to discuss about the fatigue loading and fatigue failure. So this video will give you a brief insight about the importance of static failure, the importance of fatigue failure, and what is the difference and how you can use these information to design machine components perfectly. Okay, in this video we are going to cover up these topics: static failure versus the fatigue failure. Then we will discuss a fatigue loading and types of a cyclic loading, and then last the amplitude stress and what are the different important terminology that we often used in the field of stress cycle calculations. Okay, let us discuss this thing this way. So in case of any static failure that we use, when I am using this term static, that means the load is not changing continuous with respect to that time. Suppose you have a shaft under a tensile load. Here we have a tensile load, a load that along its axis. Suppose you have some load X here on the both side, and when you keep on increasing this load, what's going to happen is that I mentioned in this graph, that the graph between stress and strain on x-axis, stress on y-axis. So at the beginning, when you trying to increase the load, it will obey the stress strain relationship in a linear way, that stress will be directly proportional to strain, and after that the proportionality things change at the point of yielding. So in case of a static loading, that you give a load and that is not change the direction or the magnitude continuously with respect to time. So in this kind of a situation, yield strength has a very important role. So yield strength is a limiting factor of this material, because at the point of yield, this material start to deform plastically. So after that yield point, when you release that loading, it will not regain its original shape. That means the point of yielding is considered as the limiting factor. So after that yield point, that material deforms, it changes its shape. So after yield, it cannot serve the purpose. So for any static load condition, we can consider this yield as a limiting factor. If it is a brittle material, there will be no yield point. Instead of that, we will be having the sudden and catastrophic failure of that material gonna fail at ultimate strength. So in case of brittle, we considered ultimate stress as a limiting factor. So here we are discussing the ductile material, but there will be certain situation that the material may fail below its yield point. So below its yield point means material may fail somewhere within this area. So when you keep on concentrating on the yield strength and material failed below yield strength, means there is certain issues of considerations. So this is the scenario when we discuss the dynamic load or the cyclic load, or famously known as the fatigue load. So why we are considering fatigue load means there is situation that a material may fail below that yielding no more a limiting factor in certain condition. So then we can now check what are the condition where yield stress will not be considered as a limiting condition. To realize that situation, I could ask you a question, that by using a machine or a universal testing machine, you can break this shaft into two. It will yield upon certain stress value, and when you keep on increasing these values, it may fail after some time. So at its breaking load, it will fail. So this is the thing that you can use with some equipments or by means of universal testing machine that we often experience in labs. But instead of that, suppose I'm asking you to break this thing into two pieces without any extra tooling, without using any machines. I'm asking you to break this into two pieces with your bare hands. So how can you do that? If I'm putting you in such a situation, you will come up with a different solution. So what will be that solution? Think about that. How can you make these into two pieces without an extra tooling? Okay, this will be your answer. So I'm going to bend this shaft into a different shape. So this is the thing that I'm going to do. At the beginning, I'm going to bend this just like this. Then I make it into its original shape. Then I'm going to bend it in opposite direction. This is all a cyclic process that I am going to do. Initially I bend into this direction and then I make it straight. Then I bend this in opposite direction. So this is the thing that I'm going to do. So suppose you do this thing step 1, step 2, step 3 continuously, and after step 3 going back to step 1, and if you keep on doing this cycle again and again, it will fail for sure. Maybe you experienced this within your childhood. So this is the situation right here. Break this shaft into two pieces by means of a static load. You have to reach its yield point. Suppose the yield point of this shaft is around some 100 megapascal. You have to reach that value to make this thing yield, and you have to keep this value higher and higher, and you have to reach the ultimate situation, and then after it will break into two. So by your bare hands it is not possible to reach this sigma y value or the ultimate stress value or even the higher fracture value of this particular material. And remember, you make these into two pieces without reaching these limiting values. So how this is possibly happening in material? So we can have a graph of these situations to understand this thing deeply. So when you consider a static failure situation, it goes like this. So if you want to make a graph between the stress and time, so on y-axis I'm going to plot the stress value, and on x-axis I'm going to plot the time. So when you consider a static load situation, the direction or the magnitude of force that we are not going to change continuously with respect to time. So if we go for a graph that a shaft which bearing some fixed load, it will goes just like this. That's a graph parallel to x-axis. There is no change in stress, there is no change in direction of the stress, but it is pretty much a different situation when you consider a cyclic loading or a fatigue loading as like this we discussed. So consider the thing that we exercised before. So here we have this shaft right here. So this will be the output that you are generating by doing this exercise. So consider a point A right here on this material which undergo this experiment. So this will be the point A. On y-axis I am taking sigma, that's the stress value. On x-axis I'm taking the time. So at the beginning there is no stress within point A, can go for 0 0. And when you're trying to bend this thing, what's going to happen? You have to closely watch. On the upper peripheral area, when you're trying to bend this thing in this direction, what is going to happen? There will be a tension that generated on this particular point. When you're trying to plot that graph, it will be like at the beginning there is no stress, then when you're trying to bend, the stress value will keep on increase, and then you back to its original position and the stress value become 0 then. So at the beginning there is no stress, then you're trying to bend, it will increase, and you back to original position, it back to 0. So this will be the graph of the half the way. And then after, we are not going to stop this process, and instead of that we are going to bend this material in opposite direction, and the same point, you have to take the same point to plot this graph. So what happens when you bend this thing in opposite direction? Instead of tension, this particular point will experience a kind of compression on this area. So you could imagine this will be the experience of this particular point when you're trying to bend in this direction. There will be a kind of compression on point A. So when you continuously draw this graph, what's going to happen to that stress and time plot? Instead of tension, we will have compression right here. So the graph will goes the opposite directions. So this will be the total effect of that stress cycle. At the beginning it goes positive direction, that we call the tension cycle, and the remaining half will be the compression cycle. So what is the difference between the static and dynamic loading? Here the value, the magnitude of stress is continuously changing, as well as the direction is continuously changing. So this is the difference between a dynamic load and a static load.